Hi everybody, I'm going to go through the review sheet for the equations test. Question number 1 says simplify the expression, and it says x minus 5 and that quantity is squared. Now what it means to square something is to multiply by itself. So we really want to multiply x minus 5 times x minus 5. And when we multiply polynomials together, we use the box method. So I'm going to draw a square and I'm going to split it up 2 by 2. So on one side, I'm going to have my first term, which is x minus 5, and then across the top, I'm going to have my other expression, which was also x minus 5. Now, to get what goes inside the 4 squares, we're going to use multiplication. So x times x is x to the second, because we're going to add those exponents. X times negative 5 is negative 5x. Then I have negative 5 times the x again, so negative 5x. And then finally, negative 5 times negative 5 is a positive 25. All right, we're able to combine like terms on that diagonal. So we're going to add the negative 5x and the negative 5x. But I always want to write my answer in standard form. So that means I want the biggest exponent first. So I'm going to write the x squared first. Then I'm going to add negative 5x plus negative 5x to get negative 10x. And then finally, I have that positive 25. So this right here is my final answer. Now, what you just want to be careful of, there are going to be choices on the test, because this is going to show up as a multiple choice question, where they're going to try to distribute. And they're going to say, oh, I get x squared, and then I get 25. That's not allowed. You can't distribute. Let me just make that a bigger cross. You can't distribute an exponent. So an exponent means you're multiplying it by itself. So we're going to use the box method instead. For number 2, we have this equation that we're going to solve, and we're going to first use the distributive property to remove those parentheses. And I notice that directly in front of the parentheses, the 6 minus n, I have that positive 5. So that's going to be what I distribute. So 5 times the 6 is going to give us 30. 5 times the negative 1n is negative 5n. And then everything else I'm just going to bring down. I'm going to bring down the 3n. That's a positive 30, so I'm going to put a plus, equals 4. Now, the common mistake I see here, and what I'm about to write in red is a no-no. People will try to cancel out. They'll say plus 5n plus 5n. But then you added 10n on one side of the equal sign, and you didn't add anything over here. So that is not allowed. Okay, but be careful, because that's what I see all the time. What we're going to do instead is you always want to look to add your like terms. So 3n minus 5n is negative 2n. So I have negative 2n plus the 30 is equal to 4. So now I'm going to subtract 30 on both sides of the equation. And I get negative 2n equals negative 26. And then finally, I'm going to divide by negative 2. And that gives us n is equal to 13. All right, let's take a look at question number 3. They want us to express the sum. Sum is addition. So we're going to be adding these together, which means we're really just combining our like terms. So I'm going to highlight my like terms. So I have 2x squared and 5x squared. I have negative 4x and positive 8x. And then I have positive 6 and negative 2. All right, so I'm going to start with my x squared, since that's my largest exponent. And 2x squared plus 5x squared is 7x squared. Then I have the negative 4x plus the 8x is positive 4x. And then finally, 6 plus the negative 2 gives me a positive 4. And that's my final answer. So nothing else can be combined, because in order for it to be like terms, you have to have the same variable and the same exponent. All right, so 4 and 5 both involve fractions in our equations, but we're going to solve them differently. So number 4 is what we call a proportion. And it's a proportion because you have two fractions that are set equal to each other. So there's only one fraction on the left side of the equals and one fraction on the right side of the equals. So whenever that happens, we can cross multiply. And I know some of you call that the butterfly, because that's going to be what we make when we draw in our two circles for our diagonals. So I'm going to multiply the 2 times the x plus 2. And then I'm going to equal that to whatever I get when I multiply the other diagonal. So 6 times the x is going to give me 6x. And now I'm going to solve this equation. So once again, I have parentheses, so I'm going to have to distribute. So 2 times x is 2x, 2 times 2 is 4. And that equals the 6x. Now, I notice that the only thing I have on the right side of my equation are x's. So the easiest way to solve this is going to be to subtract the 2x over to the right side. So then I'm going to have 4 is equal to 4x. And then I'm going to divide by whatever number's in front of the x. So that happens to be a 4. Okay. 4 divided by 4 is 1. So I get 1 is equal to x. Or you can write x is equal to 1. Right, number 5 is a little bit different. It's actually a little less work, I feel like. Because the only fraction that we have is the coefficient. So I still want to get my x's by themselves, so I have to get rid of this minus 2. So I'm going to say plus 2 and plus 2. And now I have 2 over 3x equals 18. Now the way that you cancel out a fraction is to multiply by the reciprocal. And the reciprocal is just the fraction flipped the other way, flipped upside down. So it's going to become 3 over 2. Okay, when you multiply those together, 3 times 2 is 6, and 2 times 3 is 6. So 6 divided by 6 cancels. So that will work every time. If you multiply by the reciprocal, just take that fraction, flip it upside down. It'll cancel it out. We always have to do the same thing on both sides of the equation, though. And then we can just type this into the calculator. So 18 times 3 over 2 equals 27. All right, number 6 is one of our word problems. It's going to show up on the test as a multiple choice question, so I will give you a couple strategies after of how we can narrow down choices. But let's just take a look and just dive into this one. So it says Tammy has 4 more than 5 times the amount of dimes than nickels in her pocket. She has a total of $1.50 in her pocket. Write an equation that could be used to determine the number of nickels X that she has in her pocket. So it's actually very helpful that they're telling us that nickels is going to represent X. All right, so now let's go back to that first sentence. 4 more than 5 times the amount of dimes than nickels. I feel like one of the things that makes this a little bit confusing is seeing the of dimes then nickels next to each other. Don't worry about of dimes. They're just talking about the number of dimes that she has. We're comparing it to the number of nickels because it's 4 more than 5 times the amount of nickels. So dimes is going to equal. Now, when you see that phrase more than, it tells us 2 things. One thing is more than is addition. But anytime you see more than or less than, it's one of our turnaround words. So we're going to change the order. I'm going to do 5 times the amount of nickels first. So that's going to be 5x. And then I want 4 more than that, so I'm going to add 4. So now I know I have X nickels and I have 5X plus 4 dimes. But now we're talking about money here. So if we're going to set up our equation, however many nickels we have, we're going to have to multiply it by how much a nickel is worth, what the value is. So I'm just going to set up a little guide here. So it's going to be the value of a nickel. So how many cents? Times the number of nickels that you have. Because if I said I had 3 nickels, then I would have 15 cents because it's 3 nickels times 5 cents each. Okay? Plus the value of a dime times the number of dimes we have. And that should equal the total amount of money. Okay, so a nickel is worth 5 cents. That's the value. The only thing is, since we're writing it in like dollars and cents, we're going to have to write the decimal version. So it's going to be 0.05 times the number of nickels we had, which we said was X. Okay, then I'm going to add to that the value of a dime. A dime is worth 10 cents, so it's going to be 0.10 times the number of dimes we have, which we said was the 5x plus 4. And that should equal the total amount of money. Well, the total amount of money in Tammy's pocket was $1.50. And this right here is our final answer. That's the equation that's going to help us solve. Now, I said I was going to give you a little hint for a multiple choice, right? So we said the number of nickels is X. So that means that we know a nickel's 5 cents. So you have to make sure that the X is being multiplied by 5 cents. Any answer choice that doesn't have that should be eliminated right away. And it would work for no matter what they told you for X. If they said X was quarters, a quarter's 25 cents, make sure that 25 cents is being multiplied by the X. If they said X was dimes, then make sure that 10 cents is being multiplied by the X. So that's going to help you get rid of some answer choices before you've ever even really set anything up. Okay, let's take a look at number 7. Number 7 is going to show up as a free response question. Now, there's different ways to do this. So if you are working with a tutor or a lab teacher or an extra help and you did it slightly differently, as long as you're getting the same answer, that's going to be fine because there's multiple ways to go about this. But whenever I see one of these equations that has multiple fractions going on, so it's not a proportion. We don't have one fraction on the left side of the equals and one on the right. We have 2 fractions on the left side. So cross multiplication is a no-no here. Can't do that. You can only cross multiply when you have that equal sign in between. So what we're going to do instead is we're going to find a common denominator. Now the common denominator is a number that's a multiple of each one of your denominators. So there's different ways to think of it. It can never be smaller than one of your denominators. So what I like to do is I like to look for the biggest denominator. So I have a 7, I have a 14, and technically over here I have a 1. The biggest denominator I have is 14. Can 7 divide evenly into 14? Yes, it can. Can 1 divide evenly into 14? Yes, 1 can divide into any number. So since the other denominators can divide into 14, that's my common denominator. Now, the way I like to do it is I take every numerator, so the top part of every fraction, I'm going to put it in parentheses because I'm going to multiply. And I'm going to multiply it by that common denominator, 14. So the top part of every single fraction got multiplied by 14. Okay, I'm just going to extend that line a little bit because I want to make those fractions a little bit bigger. So this first one over here, this means 14x over 7. And having that denominator is really division. That means 14x divided by 7. So, well, let's think about it. What is 14 divided by 7? Well, 14 divided by 7 is 2. So that's just going to give me 2x. Okay, then I'm going to take a look at the next one. Now, there's different ways to think about it. You can think about this next one as 14 times 2 divided by 14. Okay, so that just gives you 2. The other way you can think about it is you can think about it as, well, let's do the division first. 14 divided by 14 is 1, and 1 times 2 is 2. Okay, but either way, I have my minus sign, and then I get a 2. Over here for the last one, after the equal sign, I just have 14 times 3, and that's going to give me 42. I'm dividing it by 1, so it's not going to change. So now what originally was a pretty messy looking equation, once I multiplied by the least common denominator, it turned into 2x minus 2 equals 42. And that's just a nice simple 2-step equation. We're going to add the 2 to the other side. So I get 2x equals 44. And then I'm going to divide both sides by 2. So I get x equals 22 for my final answer. right, let's look at number 8. So this is another word problem. The length of a rectangle is 3 more than twice the width. So they told me a little bit about the length. They have not mentioned anything about the width. So the width is going to be our x. We don't know it. Okay, but the length is, I'm going to write length equals, and then 3 more than twice the width. So we said more than tells us addition, but it also tells us to change the order. So I want to do twice the width first, which would be 2x. And then since I want 3 more than that, I'm going to add 3 at the end. Now, there's a reason why we gave you a diagram. We want you to use it. Because one side is x, the other is 2x plus 3. The perimeter is the sum, or you're going to add all 4 sides together. So we know in a rectangle, opposite sides are equal. So if the top is 2x plus 3, so is the bottom. And if the left is x, then so is the right. So once I draw it all out, now when we go to combine our like terms, we're probably not going to forget anything. So if I add up all of my x's, I have 1x plus 2x plus 1x plus 2x. That's a total of 6 x's. So 6x. And then if I add my constants, I have 3 plus 3. So that's going to give me 6. And that should equal the perimeter, which they said was 60. So that would end up being choice C. Notice that they do have some distractors in there. So if you just converted the length correctly to 2x plus 3, but you set that equal to the perimeter, that's a choice. If you only added up the length and the width and not all 4 sides, that would be a choice. So just be careful, because there are some ones that are there to kind of trick you along the way to make sure you're reading carefully. All right, number 9 wants you to name the property for each step. And I think it's helpful for these to first just describe what's happening in your own words. So to go from 5x minus 8 equals 22 to 5x equals 30, they must have added the 8 on both sides so that it would cancel out. So when you add something on both sides of an equation, that's called the addition property of equality. So it'll just let you know that you are allowed to add whatever you want to an equation as long as you do it on both sides of the equal sign. Now, this property is true for every operation. You can have subtraction property of equality, multiplication property of equality, division property of equality. It just means that if you do it to one side, you have to do it to the other to balance it out. So to go from 5x equals 30 to x equals 6, they must have divided by 5. So dividing on both sides is going to be division property of equality. Now, this is going to show up as multiple choice. So as long as you understand what's happening, like, oh, okay, they divided on both sides, they added on both sides of the equation, you're going to get led to the right answer choice. All right, number 10. So here we just have a 2-step equation. I'm going to subtract the 2 over to the other side of the equation. So negative 3x equals 9. I'm going to divide both sides by negative 3. And we get x equals negative 3. All right, for number 11, we have, this time, there's variables on both sides and constants on both sides. You have some options here. It doesn't matter if you move the x's to the left or to the right, as long as they're on the opposite side of your constants. I'm going to take the 10x on the right-hand side. I'm going to move it over to the left-hand side. So I'm going to say minus 10x and minus 10x over here. Okay, 16x minus 10x is 6x. And I'm going to bring everything else down. So plus 18 equals 12. Once I decided that x's were going on the left, it means the constants are going to the right. So now that plus 18 has to go over to the other side. So I'm going to subtract it over, and I get 6x equals negative 6. My last step, divide by whatever's in front of your x. So I'm going to divide both sides by 6, and I get x equals negative 1. All right, question number 12. The total cost to make a phone call for m minutes is given by the equation total cost equals 0.35 times m plus 2. So m was the minutes, m's right here, and they're saying that if the phone call lasted 4 minutes, how much did it cost? So 4 minutes would mean that m equals 4. So I'm going to replace the m in here with a 4. So it's going to be 0.35 times 4 plus 2. Okay, we're going to type that into the calculator. Now, if you notice, the calculator is going to tell you 3.4, but this is money that we're talking about. And 3.4 would mean $3.40. So I'm just going to put that extra 0 there. And then that right there would be your final answer. Right, number 13 is a little bit similar because they are giving us a value to plug in. They want us to solve that equation for a when x equals 4. So any x value in that equation is going to turn into a 4. So it's going to become 3 times 4 plus 8 times 4. And that's going to equal 36. Well, 3 times 4 is 12. 8 times 4, we just write that as 4a because we always like to have the coefficient in the front of the variable, equals 36. So now I have my two-step equation again. I'm going to subtract the 12 over to the other side, so I have the constants together. So 4a is equal to 24. And then I'm going to divide both sides by 4, and I get a is equal to 6. All right, number 14, I have parentheses again. So parentheses should let us know that we're going to be distributing. So 10 times the x is 10x. 10 times the 5 is 50. And that should equal 5 times 3x, which is 15x, and 5 times negative 2, which is negative 10. All right, so once again, we have some choices here. This time, since in number 11, I brought the x's over to the left side, I'm going to do the opposite way this time, just to show you guys that it doesn't really matter. So this time, I'm going to take the 10x, and I'm going to move it over to the right side. So the opposite of a positive 10x is a negative 10x. I'm going to do minus 10x on both sides. And I get 50 is equal to 5x minus 10. Now, once I decided to move my x's to the right, it means the constants have to go to the left. So that minus 10 needs to get out of there. So I'm going to say plus 10 and plus 10. 50 plus 10 is 60. So 60 is equal to 5x. I'm going to divide both sides by 5 since that's the number in front of the x. And 60 divided by 5 is 12. Okay, so you didn't have to bring the variables to the right side. If you did it the other way, you would have gotten down to this line. It would have been negative 5x equals negative 60. But when you divide by negative 5, you'd still end up with x equals positive 12. So it really doesn't matter which side you move them to, as long as they're on opposite sides, the variables and the constants. All right, we're getting close, almost done. So number 15, John is selling tickets to a school concert. An adult ticket costs $12.50, and a student ticket costs $5.25. John sold 64 student tickets and X amount of adult tickets. So if you notice, I used one color to highlight the adults and one color to highlight the students. And then the total amount of money was $761. So since they told us that the X was going to stand for the adults, I'm going to start with that. So adult tickets cost $12.50, and they sold X of them. So I'm going to multiply that together. They also sold student tickets, and those were $5.25 each. And we sold 64 of them, so 525 times 64. And that should equal the total amount of money, which is $761. All right, so there's my equation that models the situation, and now we're going to solve it down here. So 12.50x plus, and then I'm going to do 5.25 times 64, and that gives us 336 equals 761. All right, we have our two-step equation, so I'm going to subtract the 336 to the other side. And that gives us 425. And then finally, we're going to divide by our $12.50. oops, I forgot the x, 1250x. And we get x equals 34. Now, always make sure your answer makes sense in a word problem. They were talking about the number of adult tickets. You are able to sell 34 tickets, so that makes perfect sense. We're just going to write a sentence. How many adult tickets were sold? They sold 34 adult tickets. All right, number 16, there are different ways that you can go about solving this. One way that I notice some people doing in class is 1/2 and 1/8 are not bad decimals. 1/2 is 0.5, 1/8 is 0.125. So some people just changed it over right away to this right here. Okay, and then they went and they distributed. And they got 0.5x minus, and then if we do 0.25 times 0.5, 0.0625. You can add that to the other side. And then my last, whoops, I got an extra 0 in there, 0.5. Okay, so now if we divide by 0.5, you get 6.125. So that's a way of doing it, just dealing with decimals the whole time, because 1/2 and 1/8 are not repeating decimals, so that works. The other way you can do it is you can just distribute. So we have 1/2 x. 1/2 times -1/8 is -1/16. And if you type this into our calculator in class, it'll just give you 1/2 times -1/8 is -1/16. And that equals 3. Now, you can think of it as the LCD way that we did before. I'll show you that in a second. Or you could just add the 1/16 to the other side. 1/2 x equals, now in our class, 3 plus the 1/16, it would default to giving you a fraction. So I'm just going to change that over for you. So our calculators in class would just tell you 49/16. And then since we have our coefficient is a fraction, I'm going to multiply it by the reciprocal, which would be 2/1. So if we take that answer and we multiply by 2/1, we get 6.125. Now in class, once again, it's going to give you a fraction at first, and then you would just hit Control Enter, and it'll switch it over to a decimal for you. So Control Enter. Changes a fraction to a decimal. All right, number 17 and 18 have to do with radicals and rational and irrational numbers. What I'm going to do off to the side here is I'm just going to list out the perfect squares. So the way that I get the perfect squares is I do 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. I'm going to stop there. That's plenty. We don't need any bigger than that. So I want to know what's the largest number on that list that I just created that can divide into that number underneath the square root symbol. So 48, sometimes what I'll do is I'll just divide that number by 2. So 48 divided by 2 is 24, but 24 is not on our list. But 24 would fall in between the 16 and the 25. So I'm going to try the next number. So 48 divided by 16, does that work? It does. I get 6, whoops, let me just change it back to a pen. So 16 times 3. So I'm going to write the square root of 16 times the square root of 3. Well, 16 is a perfect square. The square root of 16 is just 4. So that turns into a 4, and then I still have my square root of 3. All right, for the next one, 18, I always start by just dividing up by 2 and checking to see if that number's on my list of perfect squares. 9 is on the list, so I found the largest. 18 is 9 times 2, so square root of 9 times the square root of 2. Well, what is the square root of 9? 3. So I get 3 square root 2. Oops. All right, finally, this last one over here, 24 is 4 times 6. So the square root of 4 times the square root of 6. Now, I still have this 5 in the front. The square root of 4 is 2, so 2 square root of 6. But that 5 is still there, and it's multiplying everything. So I'm just going to do 5 times 2 to get 10. So 10 square root 6 is my final answer there. All right, so rational and irrational numbers. A rational number can be expressed as a fraction, so it's going to be a decimal that ends or repeats. So we'll also say decimal terminates sometimes, or the decimal repeats. For irrational, it can't be a fraction of integers. So that means that the decimal never ends and never repeats. So we also say non-terminating, non-repeating decimal. So the first one is the square root of 10. So let's type that into the calculator, the square root of 10. Now this is not repeating the exact same sequence of digits over and over again. And it's not ending because the calculator just ran out of room. So whenever it fills up your whole screen, it's not ending either. Now the other way I could tell that square root of 10 is going to be irrational is because 10 is not on my list of perfect squares. So this is an irrational number. 49 is on my list of perfect squares. The square root of 49 is 7. So that is a rational number since it ends. Okay, all integers or whole numbers are going to be rational numbers. The next one is a decimal, but that decimal ends or terminates. So this is a rational number, negative 3.25. But this last one has pi in it, and pi is an irrational number. It keeps going without repeating. All right, I hope that helped, and good luck on your tests, everybody. Make sure you study.